Usability metrics are just another type of data, and in this section we'll have a look at how we can describe the data that we associate with our usability metrics. We'll start off by identifying a rather fundamental element that ties into how we run experiments. And these are all about variables, things that can vary. We've identified two types here, independent and dependent. There's actually a third type, controlled, which we'll talk about as well. So independent variables, these are things that either we are going to control in terms of fixing them, or we're going to vary them in terms of having different values through our tests. Strictly speaking, an independent variable is something that you change through the tests. So we might be exploring a couple of different font sizes to see what's most effective from the user's point of view. And if we have a test that uses font size 12, another one uses font size 9, then the font size is known as an independent variable. We've set it up, we're going to change it through our tests. It's an independent variable that we then want to measure something that relates to that in terms of what the user thinks about or related to it. Things that we fix. So for example, that might be the color of the font that we're using. If it's fixed, it's known as a controlled variable. In our tests, we control that. We make sure that it doesn't change, that it's always fixed. They're known as controlled variables. Dependent variables then are the things that basically we want to measure. So in the experiment we're talking about here, if we're showing different font sizes, we may be asking the user then to report, okay, what one was most easily seen, what one was clear, what one did you prefer? Those types of measurements where we are getting our users, or whatever is participating inside the experiment then to determine that variable, they're known as dependent variables. So one of the key things that we're going to be thinking about here is that when we're designing our experiments, we will want to think about the things that we fix, control, the things that we will purposefully vary through our tests, the independent variables, and the things that we will measure, or dependent variables. And we're going to describe 4 different types of data, and that data can apply to all of these different types of variable, be they independent, dependent, or controlled. We'll start off and we'll show here the 4 different types of data that we're going to have a look at. They are nominal, ordinal, interval, and ratio. And in terms of the chart you can see here, they build upon one another, so to speak, in terms of their capability and what we can do with them. So we'll start off first of all then with nominal. Nominal data is very simple. It's basically an unordered group or category. So what does that mean? So it could be, for example, male or female. It could be if we showed 3 different options to the user, option A, option B, and option C, which one did they prefer? So we have a group, we have a collection of things. They are unordered. We don't say that there is a starting value or there's an ending value. They're just different values in this particular set. They're not ordered. So because of that, we can't say that one's better than the other. We can't say that one is higher than the other. One comes before the other. They're just different. And in terms of then the statistics that we can use to describe those, it's really quite sort of simple statistics. We can talk about counts, we can talk about frequencies, and that's really about it. So we could say, for example, that 60% of the users, they preferred option A. Or we could say that 55% of the test recipients, they were female. So in that sense, you can see that we can describe them, and the variables we're talking about here, they may be independent, they may be dependent. But that's our first type of data. Quite straightforward, quite simple, just an unordered collection, an unordered group, nothing more than that. Ordinal data then builds upon that. It is an ordered group. So in that sense then we have put some notion of ordering in the group. And and a few examples that we might have here would be, for example, the grades that you could have, where you might do a test and get a grade A, B, C, D, E, or a first 2-1, 2-2, and so on, where we would say that a certain one is better than another one, or a certain one is preferred compared to another one. So there is an ordering in terms of what comes before another one and what's the sequence you go through, and quite often then it's associated with a certain one being preferred or better than the other. So ordinal data, it is ordered. We've defined these categories, we've put them in a particular order. Importantly though, we can't talk or say anything about the differences between the categories. We can't say that one is twice as good as the other, or that the gap between a first and a 2-1 is the same as the gap between a 2-2 and a third. It's not meaningful to talk about the distances between them. It's only meaningful to talk about the actual elements themselves and maybe their rank ordering inside the category. So a very common example in usability studies for this is self-reported rankings, where we might go to the user and say, okay, was this excellent, good, okay, poor? So in that sense then, we're letting the user define things in an ordered series from one particular point to another point. Similar to our nominal data then, we can look at counts, we can look at frequencies, we can also throw in ranges here as well to talk about over what range of values did the data fall. That, for example, all students either got sort of between a B and a D in terms of outcomes. Interval data then builds upon this. In terms of interval data, it's the same. We have a ranked sequence, except now it is meaningful to talk about the distance between individual values. And that lets us sort of compare and measure those differences. So a couple of examples this would be dates, where in terms of the dates we can meaningfully talk about how much time elapsed between them, or things like temperature, where we can meaningfully talk about what is the difference between two different temperature values. And at this point, whenever we have them, and it's meaningful to talk about the differences between values, it opens up quite a wide range of different statistical values or statistical measurements. So we, of course, can talk about means, but we can also look at variance, about standard deviation, and other aspects around that. There's an interesting question here then about when does ordinal data become interval data? And I've got three examples on the screen which will hopefully explain this or explore that in a little bit more detail. If you look at the example at the top, so we have four options: poor, fair, good, and excellent. That's ordinal in the sense that we have defined four different variables. We've given them a particular ranking, and we can ask the user then to pick whatever one they want. It's not meaningful to talk about the distance being between poor and fair or between good and excellent. The example in the middle is a little bit more confusing because we've provided two endpoints. We've sort of said on one side you have poor, on the other side you have excellent, and we provided sort of 4 points in the middle. That is something like an interval. We're saying that there is a gap between poor and excellent, and we've subdivided that into 4 different regions, and we're looking for the user to indicate their preference through that interval. The example in the bottom is more obviously an interval. So in that sense, we also have our two common labels, poor and excellent, but now we've provided a total of 8 different points in between. So it's more clear then that we are dividing that into a spectrum between poor and excellent, and are looking for the user to evaluate whereabouts it falls inside that interval. Both are fine, quite often because we can open up a richer range of statistical tests. We will generally prefer interval type data. It's richer in terms of what we can do with it. But a good rule of thumb to use here is that if you take 2 points, for example, poor and excellent, and ask, is it meaningful to talk about a midway point between those? And if your answer is, well, yeah, you could do that. For example, between poor and excellent, something in the middle you assume would be average or okay. If that is the case, then yes, you can treat it as interval-like data. And you probably then want to, through your experimental design, make sure you're collecting enough value so that it does become interval-like. Our final type of data is actually ratio data. And this is very similar to interval, but with one important but slightly nuanced exception. So ratio data, it is all the same characteristics as interval data. We have these points, we have an order to them, we can meaningfully talk about the distance between them. But in this case, we have a 0 point that is meaningful. So we can talk about values relative to that 0. And it's called ratio data because if we have a meaningful 0, it enables us to create ratios. And by that, we can make relative statements. We can say that one value is twice as big as another. So that is relative to some absolute 0. Now, why is that important? And maybe give you an example of where that isn't so useful. So temperature. Temperature is one of the examples that we highlighted inside interval. Now, temperature does have a real absolute 0 in terms of 0 degrees Kelvin. It also it can be measured in terms of Fahrenheit, measured in terms of centigrade. It's not particularly meaningful to say that 20 degrees is twice as hot as 10 degrees, because that makes an assumption that 0 degrees is our true meaningful absolute 0, and depending upon the environment you're from, that's not going to be the case. Whereas completion time, where we measure how long it takes the user to complete a particular task, so it starts at 0 and then takes a certain amount of time, that is meaningful. There we can meaningfully say that one user took twice as long as another to complete it. So whenever we're thinking about interval or ratio data, it's important to ask, is there a 0 that is definable, and does it make meaningful sense then to say that one thing is twice as good, twice as fast, twice as great in size as another? Is that a meaningful measurement? Ratio data can't be negative under this definition, so it's not the same as a sort of numerical system. We're always talking about positive values in terms of the things that we measure. With ratio data, a very wide range of descriptive inferential statistics can be used. It sort of opens up the full range that we have available. So if we can measure this type of metric, we'll be able to analyze it in quite a rich manner. So that's all we want to look at inside this particular section. We've covered quite a wide range of different aspects about our data. All of the things then that we will be looking at, we will want to design our experiment, and we'll want to think about for our controlled, for independent, for our dependent variables, the things that we'll measure, what type of data will we collect through those measurements. And then depending upon the classification, and it's important then to think about which of the 4 different categories does this fall into, it will determine which of the statistical measurements we can use. In the section after this, we're going to have a little look then just in terms of some of the measures of central tendency, which will be a descriptive means that we can use then for a lot of these different types of data when we certainly can compare one to another.